All right, welcome on in, everybody. Looks like we only have a few people at the moment. Hopefully, we'll get some more people streaming in here pretty quickly. So, let's see, couple things. It's time we kind of talk test, right? Discuss testing coming up. So, the current material is due. Actually, what was I just looking at? Oh, yeah, that one. Okay. I was just making sure I wasn't going to show anybody's scores or anything. So the current material that we're working on is due the 10th. Right. Is due the 10th. And then I mentioned that at the end of that at the end of that unit, that module that we're doing in Canvas right now. So basically, if you come over to, let's see, if we go over to here. So you can't see it on your screen, but I will be releasing this as we get closer to it. At the end of the Systems of Equations chapters, as I mentioned, we'll be having the exam. So that means, I kind of predicted mid-October, and that's about where it's going to be. So here's how things are going to roll out. So hopefully the people that are coming in late after this will watch the video and get an update on the test. So we're looking at today's the 5th. Let me move this over. Today's the 5th, and I think we'll still have some more stuff to talk about on the 7th when we meet next time. So the 5th and the 7th will be covering new material. Next week will largely be about the exam and preparing for the exam. Okay, so what's going to happen is you should basically, up until the 10th, be working on the homework, right? So make sure you're getting the homework done. Make sure you know how to do those problems, that kind of stuff, okay? Starting on probably Monday the 11th, somewhere around in there, I'll make either Monday or Tuesday of next week, I'll make a practice test. And it won't be identical. Like, I reserve the right to change problems is basically the idea. I don't try to trick people. I don't write tests where I'm trying to trick you up, or I'm trying to see if there's one possible problem I could give you that you're not going to be able to do. I know a lot of teachers pride themselves on really, really tricky tests. I don't see the point. The problems that you see on the exam are problems that you've either done in the homework or problems that we've done in class. I mean, the numbers will be different, right? But, you're going to see systems of equations, and I'm going to give you systems of equations and say, solve the system of equations, right? You're going to have to graph lines. You're going to have to find the equation of the line through 2 points, stuff like that. There'll be 2 parts to the test. There's going to be a short written version, and then there's going to be the online version. And on the written version, you're going to have to make sure that you're showing all your work and all your steps and that kind of stuff, and then you'll be graded on all of that. The online version will just be sort of automatically graded, and we'll go through there. So we'll be still learning material this week. So around the 11th or 12th, you'll be given a practice exam. And then I think later in that week, we should go over the practice exam. Basically, we can have a review, but the reviews that I do are student-driven. Okay, so what that means is, like, I've done this in the past where I just make up some problems and go, okay, here's what I'm going to cover for your review. But then, I don't really know if those are the problems that students need to see. We're covering months worth of material, and I'm going over it in an hour. I can't cover everything. I have to pick and choose what I think students need to see. And what I found over the years is it's much more effective if it's a student-driven review. That is, you tell me what problems you need to see, okay? So they can be problems from the homework. They can be problems from the practice test. They can be stuff that you didn't understand in a video, in Delta Math, or whatever. But the review will be driven by students. You can send me ahead of time. If you have a homework problem, take a screenshot of that problem, send it to me, and I'll put it in the list and go, okay, here's some problems that I'm going to cover, and I'll go through them that way. So you can send me a screenshot. If you tell me, oh, it's this problem on this homework assignment, I can try to look at it, but you just realize mine's going to be a little bit different than yours, right? Because all these problems are randomized to a certain extent. So So it's going to have to be student-driven review. You're going to have to ask me questions. If there's no questions, then what that says to me is that you all know how to do all of the problems. And maybe that's true. Maybe you do all know how to do the problems. That would be great. If I gave a test and you all got A's, that'd be fantastic. But if you have questions, and I'm not going to call you out, right? If you send me a screenshot of a problem, I'm not going to be like, oh, Tiffany so-and-so sent me this problem. And she, it's like no one's going to know that you sent me a problem. You don't have to be embarrassed or anything like that. If you don't know how to do something, send it to me, right? That's in the classroom, I'd be getting more feedback because I'd be working more directly with you because I'd be in the room with you and I'd know what people knew and what they don't know. But online, that's a lot harder for me to know. So during that week, you're going to have to send me stuff and say, can you do this problem? I don't really understand how this problem worked. I keep doing this wrong or, whatever. Send me that information and we'll go over it. So we can kind of do that, probably the 12th and the 14th. We can go over some of that kind of stuff. So, but the thing is, if no one sends me questions, I'm just going to start going over the next material. I'll just start the next chapter because if no one sends me questions, then I interpret that as no one wants to see, there's no problems that people want to see me work on. All right, I'll just start talking about what's next. Exponents and scientific notation and polynomials. I'll just start teaching that stuff. So it's really on you as students to step up and say, yeah, this is the question that I have, and he needs to know where was I? He needs to know the question that I need him to cover. So let me know what it is. I'll set it aside, and then I'll go over it in that week. Oh, we were looking at the calendar. In that week of the 12th and 14th. So what will happen is early in this week, you'll have a practice test. Late in the week, you'll have the actual test. So what I generally do for these kinds of tests is you have a window over which you can take it. Let's see. I'm trying to remember because I use a couple of different homework platforms right now, so I'm trying to remember which one has which capabilities. But you should have even a couple days over which to do the test. So basically this homework. So maybe the 14th, 15th, and 16th, maybe the 17th. But what that allows you to do is pick a time that's going to work for you, right? So in this class, I realize, most of you at this point probably don't have jobs, I'm guessing, because it's a younger class, right? And most of you probably don't have kids and stuff like that. So those are distractions that older students tend to have. Sometimes they have kids they have to take care of. Sometimes they have jobs and stuff like that. Hopefully you don't have those, but it allows you to, but also that also means a lot of your time is decided by your parents saying, oh, we're going here today. And then you can't take the test that day, right? So what it allows you to do is pick the day and time that works for you so that no one's going to be distracting you. No one's going to be messing with you, or, your siblings are out of the house because they're at a soccer game or something, and you can just have it quiet and you can just focus on your test and do that. You will have plenty of time to take the test. I'm not one that I've never understood teachers that give just barely enough time to do a test. And especially online, I think it doesn't work because it incentivizes people to cheat. Because the more stressed you are during a test, the more likely you are to cheat. I'm hoping that you can all challenge yourselves to be ethical. You can challenge yourself to say, I'm really going to try to do this the right way and see what I can earn and learn this material and do a good job with it. I hope, right? I'm not in your room with you, but I'm hoping that's what most of you will choose to do. And then at the end, you can look yourself in the mirror and you could know, yeah, I'm not a cheater. I'm an honorable person. I act in an honorable way. I do things the right way. That's good. That's really how you're going to end up being successful in life. Usually trying to get ahead in life by cheating it doesn't work. So that's what I hope by giving you a long period of time to take the test, where I give you hours for a test that should take you less than 1 hour, maybe around an hour. Some students might take an hour and a half or something. It just depends. Sometimes I'm surprised and a student will take an extra long time. But you might have a really long window, like hours to take the test, so you don't have to stress. It's not like you have just enough time to work through the test. You're going to have plenty of time to take the test. Okay, so pick the right time you want to take it and then take it. The rules, the way it works for tests will be a little bit different on the test than for homeworks, right? It's gonna you don't get the retries and stuff like that you get on the homework. But again, I'm hoping that you'll choose to do things ethically, challenge yourself to take the ethical route. And then there's going to be a written portion. There's going to be one where I want to see your work. I want to see you write it out, so you can't just put it in and some apps show other stuff too. But it's not like you just get an answer back and then you can put it in and cheat or whatever. So there's going to be both. So you're going to submit a written portion and an online portion. You'll have practice tests for both of those. So they shouldn't be a shock to you. You shouldn't be surprised what you see on the test. Again, I'll change problems, but it's not like I'm going to completely change them. You shouldn't be surprised when you see a problem on the test that says solve this system of equations, right? That's a whole chapter, systems of equations. Don't be surprised when you see it. Graphing a line. I've been telling you all along, I have to test you and make sure you can graph a line. It's one of the most important topics from this class because even in statistics that doesn't involve a lot of algebra, even in statistics, understanding the equation and graph of a line are, you need them in statistics. Calculus, you need to know how to graph a line. People go, oh, well, calculus? Aren't we well past graphing lines? No, calculus is built on a thing called a tangent line, which is, it's a line, right? It's a type of line. So you'll have some heads up as to what the problems are going to look like, roughly, right? I reserve the right to change them, but you'll more or less know the type of stuff on the test, and you should know it anyways, right? It's the major topics from the course. I'm not going to find some really obscure, weird problem and make you try to figure that one out. If you've been doing the homework, if you've been learning it along the way, and you do some studying before the test, you should be fine. Right? And that's what the practice test is basically to get you to do some studying. And then later in that week, you'll take the actual exam. And here's the good news. Even if you completely bomb the test, no worries, you're okay because you get to take a retake. So keep that in mind again when you're deciding, are you going to be ethical on this test, or yeah, I could cheat here and I probably wouldn't get caught. Just don't do it. Just know you have the safety net that even if you totally bomb the test, you can retake the test and still get 100%. So just try to take a shot at doing it right the first time, right? And you'd be surprised, us teachers are learning more and more how to spot cheating online. And we're sort of sharing within each other how to figure out when people are cheating online and stuff. And it's sort of surprising how sophisticated we're getting. But of course, people are going to be able to cheat online. So I challenge you, just try to do it right. Worst case scenario, you take the test, you bomb it, you still get another chance at it. Okay. So, and those retakes would probably happen in this week, sort of about a week later after you take the actual exam. But we'll talk about retakes when the time comes. This is a pretty small class, and most of you are doing quite well. So maybe we won't need any retake at all. That would be awesome, right? If you all just did well on the test and we didn't need to worry about retakes. But, here's a great question. Are calculators allowed? That's a good question. Let me see. Was this the class? I got all these different classes. I'm trying to keep them straight in my head. Let's see. For systems of equations, you should not use a calculator. For linear equations, you should not. Solving systems, formulas, ratios, exponents, real numbers. The only one where you could make any case is like percents and proportions. Some of those problems got a little bit weird, but I don't usually give a ton of those. So I would say no. The answer is no. You shouldn't use a calculator on the test, and I usually try to give problems where calculators are not necessary. And in fact, a lot of times what I see is students relying on calculators for a test, and then it hurts them because then they end up giving the wrong answer. For instance, if the answer is 1/3, but the student puts 0.33, well, 0.33 is not 1/3. It's close to being 1/3, but it isn't 1/3. So a lot of times students actually lose points because they're so used to a calculator that they don't really understand how to do the algebra without a calculator, and then they get it wrong. right? So, and that's kind of the example. 1/3 is not 0.33. It's not 0.33333333. It's not any of those. You cannot write 1/3 as a decimal without, maybe if you're at the little bar. But the students using calculator don't do that. So, no calculators, and really just get comfortable with not using the calculator, because as you move through algebra, most of your teachers are not going to want you using a calculator in algebra. There's like 2 sections where we need it. There's one when we do exponential growth. A lot of those things you're not going to be able to calculate by hand. And I forget what the other one was. I think it's when we do like percents and stuff and you get all these decimals and it just gets really messy. But I'm not likely to ask you a question like that on the test. So generally I write tests that you shouldn't need a calculator. If you've done the homework and you understand how to do those types of problems, you should be able to do the test without a calculator. Okay, but that's a great question. I'm glad you asked. So just be prepared for that. So just go back. Usually people don't have to review order of operations in like chapter 1 very much, because that was review anyways. And hopefully you've been, the truth is you use order of operations and all this add, subtract, multiply, divide. You do that like every problem you do in this course. So usually people are pretty good and they don't have to review that. Solving equations, you probably get the addition and multiplication rule. You're probably comfortable with those. Graphs, I'm going to make you graph lines. I'm going to make you find equations of lines. Guaranteed there's going to be a problem that says, here's 2 points, find the equation of the line that goes through it. That's probably going to be on the written portion of the test. I'll have you do some stuff with functions. Make sure you understand that. And then I'm going to have you solve some systems of equations, right? So just know those basics. Again, I'm not going to try to trick you. I'm not going to try to come up with some obscure problem. I just want to know if you know the material, right? Can you solve a systems of equations? Can you graph a line? Can you find the equation of a line that goes through 2 points? If the answer is yes to all those, then it's good. I think you're ready to move on to Math 3, right? Let's move you forward. I'm not trying to trip you up here. Okay, so that's kind of how that'll go. We'll talk more about the test as we come, but just so you know, we're looking at now. You have a little over a week's notice about the exam. Okay, so the exam is likely to hit like next Thursday. A week from Thursday is probably when the exam will become available to you. Maybe Friday, but we'll see. Probably Thursday. So we'll talk more about that then. Okay, if there's no questions, then in the meantime, we need to actually finish learning the material that we need to learn so you can finish the homework and do the test. So we were talking last time about systems of equations. So this has been building, and this is, again, a really important area of mathematics. We talked about systems of equations graphically. We'd graph 2 lines. The point of intersection was the solution. Boom, we got it. And then we started saying, well, we need a more powerful tool. We need to be able to solve systems of equations algebraically. So last time we looked at substitution. Substitution's great. Substitution is usually people's default, I find. The people just go to it every time. I was a little different, like in grade school when we learned systems of equations. I just kind of liked the elimination method. Substitution method's fine too. It doesn't really matter which one you use. You should choose the one that you think is going to be easier for the problem that you're working on. So we looked at substitution. Remember, we said substitution is a great choice when one of the coefficients in one of your equations is a 1 or a negative 1. So if you have an x or a negative x or a y or a negative y, substitution is probably going to be your easiest method to get that problem done. So then that leaves the question, what if I have a systems of equations where every variable has a coefficient that is not a 1 or a negative 1? It's a 2 or a negative 3 or a 5 or a 7. That's where elimination method, also known as addition method. So if you learned the addition method in the past, that's the one we're talking about. Addition, elimination, same thing. Just different books call it differently. If you have a systems of equations where none of the coefficients in your equation are a 1 or a negative 1, probably elimination is going to be the easiest way. And then there's all sorts of problems where it's about the same, right? It's about the same amount of work. Doing it one way versus the other doesn't really make any difference. But it's up to you. I have students that solve every single problem using substitution. Okay, if you get the answer right, I don't care, right? My main thing, we have to teach you both methods, but I'm not going to get bogged down in I wanted you to use elimination on this and use substitution. The reality is, if you can solve a systems of equations, then you can solve a systems of equations, right? And you're ready to move on to the next class. You really will be better off if you learn both methods. So I'm not trying to say like just use one, because I've seen students do a ton of extra work on a problem because they wanted to use substitution instead of elimination. And with these kinds of problems, the harder you make it, the more likely you are to make a mistake. So it's in your own best interest to choose the easier method. Plus, like I've mentioned, a lot of these methods spill over into other related topics that, it's helpful if you're comfortable with these ideas. So, but what I'm saying is, like, if I give you a systems of equations problem and you use substitution, I'm not going to be mad that you didn't use elimination or something like that. Like, I want to know that you can solve systems of equations. Okay? So let's talk about elimination. So elimination is just a different method for solving these. So okay, that looks good. Let's look here. We're going to start off with a problem that is really easy, just to walk you through the steps so that you can see sort of the idea behind this method, right? So it's going to look like, wow, you did that whole problem in a few lines? Yeah, because it was set up to be done in a few lines. Then we'll get into the more complicated versions where we have to work a little bit more at getting the problem done in order to finish it. So let's see. Let me get, oops, why is, oh, it didn't recompile. There we go. That works again. Okay, so let's go up to the top, and we've got, I don't think I need that. Let's see, where's my system? Here we go. That's really weird. I don't know why it's formatting it like this. There we go. That was weird. There's just a compile error because of some other code I had elsewhere in the script, but it doesn't matter. So here we have a systems of equations, right? Now, notice that none of these variables has a 1 or a -1 on it. So, yeah, you could do this problem with substitution, and as long as you don't make any mistakes, you will get the correct answer. But notice that any like the first step of substitution is to solve one of the equations for one of the variables. Well, choose any variable up there you want and solve for it. You're going to end up with fractions, right? Let's say I take this 3y right here. If I want to solve for this, that means at some point I'm dividing by 3. That means I'm going to have a 5/3 on my x and a 2/3 over here on my constant. Now I'm dealing with fractions. I'm adding, subtracting, multiplying, dividing, maybe fractions. I don't want to do all that, right? So you can use substitution if you want, but this problem can be done without having any fractions at all. So I'm going to do it that way, right? In math, easier means fewer mistakes generally. So simpler, easier, simpler, fewer mistakes. So we're going to use the elimination method. What you do, so the substitution and elimination methods, they only differ in the first half. The second half of these two methods is the same. That is, once you have figured out how to solve for one variable, so like remember in substitution, you'd pick a variable, you'd solve for it, and then you'd get your x, and then you had to go back and solve for your other variable. This second half of this problem is going to be just like that. Once we get one of the variables solved for, you just plug it in and solve for the other one. So that half of the problem is the same. The way these two methods differ is in the first half. If you remember back to the substitution, we made the substitution, and then all of a sudden we would end up with an equation that had one equation, one variable. And then we know how to solve that, right? That's our goal here too, is we want to end up with one equation, one variable. So how do I make that happen? Well, we just do it a little bit differently than we did for substitution. What we're actually going to do here is add the equations together. Excuse me. Now that's kind of a different step where you go, wait. Sorry, I'm getting the hiccups here. You go, wait, I'm actually going to add equations together? That's not like a thing we've done in the past. And you might go, well, why can we all of a sudden add equations together? And actually, that's a great question, but it's sort of hard to justify in this course right now, right? Basically, if you take linear algebra down the road, so those of you who are going to become engineers or scientists or something like that, you'll take calculus, and then on the other end, you take linear algebra, and you'll justify why this is a legal step. For now, just trust me. We are allowed to add these equations together, right? Sort of think of it as two balances. If a balance is balanced, if I have two balances and they're balanced, and I put all the stuff on one balance, they still should balance, right? As long as the sides match up. So we can add these equations together. Now, we want to do it in a strategic way, in a smart way. So we want to add the equations together in a way that's going to get one of the variables to cancel. And you can see that right here, we're already set up for that. That's why I was saying this problem at the beginning is going to be kind of easy, because usually what's going to happen is you're going to have to do some work to get these y's to look like this. And it doesn't matter if you eliminate the x's or the y's, but in this case, the things that's going to cancel is the y's. You're going to have to do some work to get it to be plus 3y and minus 3y, because when I add plus 3y and minus 3y, the y's just go away, right? If I have 3 apples and you take 3 apples, I have no apples now, right? So that leaves us with a 0. That will leave us with one equation and one variable. So we're getting to skip the step for this problem where we have to make this match up. So I'll do a problem like that in a moment, and then we'll take a look at it. But for now, what's going to happen when I add these equations together? Well, then I get 7x equals negative 14. Right? 5x plus 2x is 7x. 3y plus negative 3y is 0. And 2 minus 16 is negative 14. Now divide both sides by 2. And we're going to get x equals negative 2. X equals negative 2. Okay, and then from here, remember, now we just do the same thing we did before. Now I would plug negative 2 in for one of our x's up here and then solve. So if I took this first one and plugged it in, let's move this over a little bit. All right, plug that in. I'm going to get 5 times negative 2 plus 3y equals 2. Negative 10 plus 3y equals 2. So that's going to give us what? If we add 10, we're going to get 3y equals 12. Why is this not recompiling? What's going on? Somehow it turned itself off. That was weird. I just checked the auto recompile was on, and then it turned itself off somehow. So 3y equals 12. And y equals 4, right? So then we've got x equals negative 2, y equals 4, which is correct. If we plug those values in, remember, it's easy to check your work for systems of equation, and it only takes a fraction of the time. Just plug them in. Okay, what is going on here? I don't know why it won't compile all of a sudden. Okay, there we go. So sorry about that. I don't know why the software just decided to stop working all of a sudden. So x equals -2, y equals 4, right? The second half is the same. I just took my x equals 2, plugged it into one of the original equations, solved for the other variable. If we plug these in, I'm going to get what? -10 plus 12 equals 2. Yep, that's true. Okay, -4 minus 12 equals -16. Yeah, that's true. Okay, so then we know that our answers are correct for this system of equations. So you can see what we did. We had these variables that were going to cancel. So we added them together. They indeed did cancel, and we were able to solve for one of the variables. That's what there is to this type of problem. Now, with that said, what we need is to we need to figure out, what do I do with problems when it's not already set up for one of my variables to cancel? And that's where we want to look a little bit closer at things. So let's do another problem. And then let me make sure I got my problem correct. Trust me, and I've done this before, but students do this a lot where they copy the problem down wrong, and that's why they miss it. So always double check. Okay, got the problem correct. Now notice this is different than the previous problem. Looking at these, I don't have a variable that's all ready to cancel. What we have to do is multiply equation 1 by some value, and then multiply equation 2 by a different value that's going to get the variable to cancel. Okay, now sometimes I get students, they get it in their head, we're supposed to multiply equation 1 and equation 2 by the same thing. But if you multiply equation 1 and equation 2 by the same thing, you're still going to end up in the same issue. You're not going to have variables that are ready to cancel. So we have to decide, what do I want to multiply equation 1 by? And what different number do I want to multiply equation 2 by? Now this is, when I say multiply the equation, this is the same thing we did in earlier chapters where you multiply the entire equation by something. Okay? We're not just picking certain things. We're multiplying the entire equation by a value. So you can pick the x, the room could split. Half of you eliminate the x, half of you eliminate the y. It doesn't matter. There's no right or wrong answer about which variable should I eliminate first. It doesn't really matter. You should eliminate the one that you think is the one that's going to be easier. Yeah, so someone's asking, video quality dropped. Is it? Yeah, it's -4y. Sometimes YouTube does that on the live streams. If you hit refresh, sometimes it'll come back with better video quality. Sometimes the audio gets messed up too. So if you hit refresh, it might fix it for you. Because it's on the stream, because I watch the stream as I'm doing it to pick up problems, and it's still coming through pretty clean on my end. So if you refresh, I think it'll fix it for you. But yes, it's a -4y. Okay. Okay, so in this case, I actually would argue that it's easier to get rid of the x. So some of you might be looking at it and going, oh, that looks like the x might be easier to get rid of. It probably is. But I'm actually going to get rid of the y, mainly because I want you to see how to do one of the more complicated problems so that you know how to do it, right? And then getting rid of the x, on future problems, you can do the easier one, whichever one's easier. So I'm going to eliminate the y's. So what I'm going to ask myself is, what's the least common multiple of 5y and 4y? What's the smallest number I can multiply these together to get that will then cancel out? So it's your least common multiple that you're looking for, right? So the smallest number that 5 and 4 both divide into evenly is 20, right? Okay, so then you have to ask yourself, what do I multiply to get a 20y in each of these? And notice how the signs are opposite. We need that. Sometimes students work to get a plus 20y and a plus 20y, but then when you add 20y and 20y, you get 40y, not 0y, right? So remember, the signs have to be opposite. Now, we've lucked out that they're already opposite, But if you have one that is not opposite, then you multiply by a negative value, right? In other words, if you need one of those terms to be negative, then multiply by a negative to get it to cancel out. If that doesn't make sense, go ahead and ask. But so here's what I'm going to do. I'm going to multiply, and I'm just going to use this notation. E1 will mean equation 1. E2 will mean equation 2, right? So multiply E, it just saves me space since we only have so much space that I can show at once. So multiply equation 1 by, well, if I want that to be 20y, I should multiply by 4, right? I don't know why it's giving me so much trouble today. Multiply equation 1 by 4, right? And then multiply equation 2 by 5. That's what we're going to do. And if both of those were positive, we would just make one of the things we multiply negative so that those signs are opposite each other, right? You have lots of choices in this problem. Like we could probably have a dozen people do basically the same problem, but make different choices along the way. Your work would look very different, and then you'd all end up with the right answer at the end. So there's not like you have to do it this one exact way. As long as you're following this overall procedure, you're fine. And apparently I can't spell multiply. Okay, so if I do that, here's what I get. Multiplying equation 1 by 4, I get 36x plus 20y equals, what's 16 times 4? 64? Is that right? 36 plus 20 equals 64. Okay. Now when I multiply equation 2 by 5, I'm going to get 15x minus 20y. See, that's the reason we did that, is so those 20y's would cancel. So good, we're on the right track. Equals, let's see, negative 6 times 5 would be negative 30. So this system of equations, which we now have, oh my gosh. This system of equations that we now have is equivalent to the first systems of equations. That means it has the same solutions. But good news, we now are going to get that cancellation that we want. So my next step is going to be to now add E2 plus E1. I don't know why I wrote them in that weird. Let's do it this way. Yeah, okay. I said E2, but I wrote E1. Now add equation 1 and equation 2 together. Okay, what happens when I do that? Well, then I get, what do I get? 51x. My y's are completely gone. Equals 34. Is this the one with a fraction in it, I think? Yeah, okay. Okay. Some people panic at this point because they go, oh, that's going to be a fraction. I messed up. Right? I'll literally get this question in class. Someone will call me over and go, I know I made a mistake. How do you know? Oh, because I got a fraction. It's totally legitimate for you to have fractions in your solution. In fact, it's legitimate to be forced to have fractions along the way, but sometimes we can avoid them. In this case, we cannot. So we're going to go, what does that come out to? X equals the fraction, let's see, 2/3? Because you divide by 17. You get 2/3. So x is 2/3. Okay. Sometimes you're going to get fractions. And you go, where are we? So then you plug, so now it's just like the other problems, right? And for the sake of time, I'm going to skip this part. Now you just plug x equals 2/3. Well, okay, let's go through it. So I would take 9 times the fraction 2/3 plus 5y equals 16. Wow. Software is really frustrating me today. I guess their server's having trouble, but I don't know why. It keeps saying their server's getting hit, and then it changes where it won't compile. Okay, so all I did was take x equals 2/3, plug it into equation 1. This is going to give me what? So divide by 3 would be 6 plus 5y equals 16. So it looks like y is equal to 2. Yes. Y is equal to 2. That's right. Y equals 2. And then we've got our solution, and we can check it just like normal by plugging these values into the original equation. Okay? So just like always. So I think I talked about this last time, but I don't think I actually did an equation. Let's look at one with the weird types of solutions, just to make sure we know what those look like algebraically, and then we're probably pretty much out of time at that point. Okay, so I want to solve the systems of equations. Nothing about it looks weird, right? It just looks like okay, you handed me a system of equation. I'm going to go through and solve it. So I'm going to start working on that. To me, this problem screams out, I should probably use substitution because, look, it's already solved for one of the variables. So why would I mess around with elimination if it's already basically set up for substitution? I'm just going to use that. So I'm going to use this substitution into the second equation. So this one would become 8 times, actually that would just be, 8x minus 4 times, y is the one we're substituting, 2x plus 4. I don't think I did this one last time. Tell me if I did this one last time, but equals 7. So see, all I did was perform the substitution there. So this will become 8x, that should be that should be a 4. I have a typo in here. See how the 4 stays the same right here, and the y became the 2x plus 4. That was my that's my substitution. I had a typo in here a second. So if that confused you, go ahead and ask me about it. Okay, so that's going to give me minus what? Minus 8x minus 16 equals 7. But look what happens in this problem. 8x minus 8x, man, all my variables are gone, and I end up with negative 16 equals 7. Well, negative 16 never equals 7. It doesn't matter what you pick for x and what you pick for y. Negative 16 cannot be equal to 7. Those are just intrinsically different numbers. So this is our no solution scenario. Solution's always one of those ones. I always try to put 2 L's in solution, but there's only one L in solution. There we go. Okay, so that's where you get no solution, and sometimes they use the circle with a line through it. Again, that's not a 0. That's the symbol for the empty set. It's saying the set of solutions is empty. There are no solutions in the solution set. They're pushing that on younger and younger groups, and it ends up confusing people because they think it's a 0. The books and the exercises, are pushing that on earlier and earlier, and I think unnecessarily. But at the end of the day, just recognize that this answer is no solution. If you get the same number on both sides, so it's a true statement, that means you have the other one where those lines are right on top of each other, and you would answer the solution that way. I believe we talked about that last time. Okay, so that's how you do those types of problems. Okay, and there's not really time to do another problem. So is there questions? Is there any question on how I do the elimination? Is there a question on those weird solutions where you get either no solution or you get the infinite number of solutions? Or is there any questions still about the exam coming up? We can spend our last few minutes discussing that if anyone would like to. Okay, I'm not seeing any questions. So Anyone who wants to speak with me, why don't you jump over into Zoom? Or if you're already in Zoom, then you're already there. But anyone who wants to talk to me about anything course related, come to Zoom. Otherwise, I'm going to shut down the YouTube stream. And I will see you all in a few days. And so just start trying to get ready, right? If you're a little behind on the homework, get yourself caught up. Start reviewing some of those old sections you looked at weeks and weeks ago. Just look at them again. Refresh yourself. 15 minutes a lot of times is all you need to go, oh, that's right. That's how you do those problems. Start spending a little bit of time each day getting yourself ready for the test, and I think you'll all be fine. Okay? All right. Sounds good. See you in a few days.